This video is about Lab 0.5 in CS140 at the University of Tennessee, spring 2018. So in this lab, you are going to make a program that reads a map on standard input, and this map is either going to have a period, so period stands for dirt, it's going to have a dash stands for a rock with nothing underneath it. So really a period, a dash, we don't care about. But any other character is going to be an uppercase letter. And depending on the letter, that's going to tell us how much gold is underneath the rock. So if you see an A, you have 1 ounce of gold. If you see a C, you have 3 ounces of gold. If you see a D, that's 4 ounces. If you see a Z, the last letter of the alphabet, that's 26 ounces. And you're guaranteed to only have those characters. You don't have to worry about lowercase letters or a percent sign or anything else really random. Just going to see these 3 things: period, dash, or uppercase letter. So as you're reading through this, the goal, as you can see below, if you keep on reading, is that you want to print out the total ounces of gold on your map. And one instant thought might be, okay, I'm just going to read in char by char, and every time I see an A, I'll add 1 to my gold int, something to keep, like a program counter to keep track of how much gold I have. And if I see a B, I'll add 2. If I see a C, I'll add 3. A D, I'll add 4, da-da-da-da-da. And so thinking like this, you're probably thinking, okay, then I would just have 26 if statements. But 26 if statements is a freaking ton of if statements, and it would look really ugly. So there's got to be another way, right? And there is. That's what we want you to do in this lab, is the other way. So if you do a quick Google of the ASCII table, this is the key to not having 26 if statements in your lab. So let's take a look at some images. If you Google it, pick the first image. This is an ASCII table along with all the other images that pop up. And what the ASCII table is it tells you what each character actually is as an integer underneath the hood. So if you didn't know this already, every character in C and C++ is actually represented by an integer. So a capital A is internally a 65, actually. And the letter Z is actually a 90 internally. So what really helps out here is that in the ASCII table, we have the capital letters in alphabetical order. So A is 1 int off from B, just 65, 66. B going from C is 66 to 67, all the way to Z, which is exactly how our gold works. A is 1 ounce, B is 2 ounces, C is 3 ounces, etc., etc. So that's going to be really helpful. So let's pull up a little terminal window to talk about this. All right. So I'm going to go into my gold.cpp file. I already started it a little bit. So I have an int called gold value and a char called map unit. So the map units are going to be the little pieces of information that we read in here. So this period would be a a map unit. This period would be a map unit. This capital A would be a map unit. Those are what my map units mean, and the gold value is that gold value that I want to spit out at the end, is the number of ounces of gold I have in the map. So let's just assume that you can read in the map unit here. Skip over this part, just in case it gets mad at me compiling. And let's talk about the map units. So let's just say the map unit, let's just make it an A right now, hard code it, but pretend it's actually whatever you read in here. You read it in char by char, and what you read in last happens to be an A, so I'm just going to hard code it to make our example work. So one thing that I can do, because chars are actually ints underneath, so remember chars are actually ints internally, so I can do something like this and it won't yell at me. Gold value equals map unit, and let's see what happens. So if I see out map unit equals this, map unit, and I see out the gold value, what are we going to see? So map unit was A, like we hard coded in, and it prints out the letter A. But if I want to print out the gold value, remember I set map unit equal to the gold value. Now it prints out 65. And in the ASCII table, capital A is equal to 65. So that's really handy, except that I don't really want A to equal 65, I want it to equal 1. So how are we going to fix that? Well, there's some pretty easy ways to do so. Okay. So right now, like we said, gold value is currently 65. So one way to make it 1 is just say, okay, gold value equals gold value minus 64, right? That would work. So if I see out changed gold value equals gold value and L, although I'm telling you I'd count off for this ahead of time. Do not do this, it looks ugly, but I'm going to show you that it works. Change gold value equals 1. So like I said, that's pretty ugly. Please don't do it. But it does work. What is a little nicer, a little more elegant? Well, like I said before, chars can be manipulated like integers. So stuff like this also works. When I say gold, let's say gold value back. Well, I can do this. Gold value equals A. That would set it back to 65. I can also say gold value equals gold value. So now this is back to 65 minus A. So underneath the hood, this is really 65 minus 65. So that would be 0. This is a lot more elegant than this line, gold value equals gold value minus 64, because if someone else reads it, they have no idea why you're subtracting 64. You'd have to have some pretty clear comments, and it still would look kind of ugly. You would have to look up the ASCII table to make sure that 64 is actually the number on the ASCII table that you want. And typically when you do ASCII manipulation, you don't want to actually have to look up the ASCII table. It's a little bit of a burden. And what happens, like for some god-awful reason, they change what the letter A actually is. It's suddenly next year not 65 anymore, but 66, then your code is messed up. So this line right here is a lot nicer way of doing things. So of course you don't want it to be 0. We don't want 0. We want 1 to equal the letter A. So that's pretty easy. All I have to do is add on a +1 here. Not that bad. This is still a lot nicer than minus 64. So no matter what the gold value is, if gold value happens to be a B, so let's make a new variable just called gold, total gold, I guess. Total gold. And call this total gold. If my gold value was the letter A, if that's what I read in, and then I subtract A and add 1, then I'm going to be adding 1 to my total gold here. In order for this to work, total gold has to start out at 0. So in this case, we would get the correct value of total gold. If this happens to be read in as B, then B underneath the hood is 66 minus A, 65, plus 1. So 66 minus 65 plus 1 is 2, and that's what we want. C would be 67 minus 65 plus 1. That's 3. That's what we want. Go through all of them in your head. It all works. So this is the elegant way of doing that. Now you also really don't care if you see a period or a dash or anything but the capital letters A to Z. So you can also just skip over really any letter that's not a capital letter, and you can do ASCII manipulation by doing that too. So if we're reading in, so now go back to pretending that we read in a map unit just now. So pretend like I just read in a map unit. So map unit has something inside it. Is the map unit greater than or equal to A? Notice that I'm putting A in single quotes. We have to put these charts in single quotes because double quotes indicate a string. So is the map unit greater than or equal to A? We want to know that. Is it greater than or equal to M? We don't really care about M, but you could do that too if you want to. So what's in the parentheses right here? The parentheses starting here and ending here, the statement inside the parentheses can actually be used as your statement inside an if statement, and that would evaluate to true or false, just like a number. Because remember, we really just replaced this with 65 internally. Is map unit greater than or equal to 65? And it still works. So that's pretty freaking awesome. So again, you can use that to just isolate the capital letters only and forget about the period and the dash. All right, again, this is CS140 Lab 0.5 gold.cpp.